LINQ to SQL is part of ADO.NET. And if you ask Microsoft what it does, they'll tell you it bridges the gap between object programming and traditional database programming. So in other words, when you program against objects, you're working with classes. And when you program against a database, you're working with SQL statements, which are just big strings. So what LINQ to SQL does is try to close that gap. And it does it by providing you an abstraction layer over your data and ADO.NET. So what you do is you map the structure of a SQL Server database to an object model. So for example, Northwind database has a customers table. You'll create a customer class. It has a products table, an orders table. You'll create classes for each of those. And then you'll use LINQ to query and change the data in your database by programming against the object model. So what are the key constructs involved in mapping data to objects? Well, the database is going to map to the data context, and the data context represents the database, and it's the main way you work with the database. Then the tables and views in the database will be entity classes in your object model. So the products table will map to the product class, customer table map to the customer class, etc. Columns in a table or view are going to be properties in a class. So the customer class will have properties for company name, contact name, address, city, etc. There are relationships between tables, and those are represented by properties. In the database, tables are related, and the relationships are going to be represented by properties. So for example, the customers table is related to the orders table. Therefore, the customer class will have an orders property. And that property is a collection of instances of the order class, and it represents the orders for that customer. And then finally, stored procedures will appear as methods. The data context class manages the interactions between the database and your entity classes. So this is how you'll connect to the database. You can retrieve information. The data context class has a getTable method, and you can use that to bring down information from a table. The data context is also in charge of tracking changes, and then it has a submit changes method that you can use to send changes back when you want to save your data. Each of the entity classes are properties of the data context. So if you want to work with customers, and we'll see this in the demo, you'd use the customer's property of a data context. And here this data context is pointing to Northwind. And as I said, stored procedures are methods. So in this little code snippet, we're going to call the customers in region method of the data context, and that calls the customers in region stored procedure in SQL Server. We pass in a region, and then this will then return all of the customers in that region. Each entity class in your model represents a table or a view in the database. So our object model will have a customer class, will have a product class. How do you know which table those classes are mapped to? Well, the class definition will use a table attribute to identify the table or view the class represents. And then that class has a property for each column in the table or view. How do we know that the company name property in the customer class maps to the company name column in the customer's table? It's not just because they have the same name. It's because in the definition of the class, that property will use a column attribute to identify the column it maps to. And we'll see this in code when we get to the demo. Each entity class can contain a collection property for related tables. So the customer class will have an orders property that represents the orders for that customer. And in the object model code, that property uses the generic entity set class to hold the collection of entities representing the child side of the relationship. So in other words, the orders property of the customer class will be an entity set holding a collection of order classes. And then there's an association attribute that identifies the primary and foreign keys. Now this is important because when you save the changes, when you call that submit changes method of the data context, the CLR needs to know how to get the properties of the classes back into the real live data. So LINQ to SQL is going to generate a SQL statement, send that on to SQL Server, and it constructs that SQL statement by knowing how the properties map to columns. And that's all done through attributes. And on the other side of the relationship, the child entity class uses the entity ref class to reference the parent. So the order class will have a customer property, and that property is an instance of entity ref, and that's going to point to an instance of the customer class, specifically the instance of the customer class for the customer that placed the order. And again, that will use an association attribute to identify primary and foreign keys. So the parent class has a collection property that represents the child classes that belong to it, and the child class has an entity ref property that references the parent. Well, how do you create an object model? There are at least 3 ways that you can do this to map your database model to an object model. The first thing you could do is write the code yourself. This, of course, requires understanding the table attribute, the column attribute, the association attributes, and literally what structure LINQ to SQL is expecting. But once you understand that, you could write the code yourself. In all likelihood, though, you'll want to use a tool and have Visual Studio do it for you. But in all likelihood, you don't want to write the code yourself. So you have a couple choices. You can use a command line tool called SQL Metal to generate the object model for you, or you can use the Object Relational Designer in Visual Studio. So let's go see a demo of creating an object model using the Object Relational Designer. Let's create an object model. Well, the first thing I'm going to do is create a new project. And I'm going to create an empty project. I'm not actually building an application. I just want to build an object model. So I'll select Empty Project as the template, and I'll call this Object Model Demo. And I'm going to add a new item to this project. And I'm going to use the LINQ to SQL classes template. And this gives me the ability to build LINQ to SQL classes mapped to a SQL Server database. So I'll call this Northwind and add. And Visual Studio brings up the Object Relational Designer. I'm going to hide the Solution Explorer for the moment, get a little bit more room here. And I can use the Object Relational Designer to build my model. And to do that, I can drag tables from the Server Explorer onto the Object Relational Designer. So in the Server Explorer, I'm going to create a new connection to a database. And I'm going to be using SQL Server. LINQ to SQL supports only SQL Server. So I'll use SQL Server here. And I'm working with SQL Express, SQL Server Express. So my server is ./SQL Express, and I'm going to connect to the Northwind database. Now in the Server Explorer, I can expand that connection, and here are the tables from Northwind. So now to build my model, all I need to do is drag tables onto the Object Relational Designer. So I'll start with customers. I'll drag that on here. And now I get a customer class. Notice it's not called customers. Customers is a collection. Each individual customer is represented by this customer class. I have properties for each of the columns in the table, and I can see that customer ID is the primary key. And if I look in the properties window, I can see that the source for this class is customers. Okay, let's add another table. I'm going to add orders. And I know that there's a one-to-many relationship between customers and orders in the database, and that needs to be reflected in the model. Well, this line between customer and order is an association line, and I can see that there is indeed a one-to-many relationship. And I can see that the customer class will have an orders property, and that's going to contain a collection of instances of the order class. And in the order class, I'll have a customer property, and that points back to the instance of the customer class, or the customer that owns the order, if you will. Well, if I select this association and look in the Properties window, let's pin this for a second. There's the association. It's called Customer Order. I can see that the customer and order classes are linked by customer ID. It's a one-to-many relationship. and customers the parent, orders is the child. Okay, let's add some additional tables. I'll add order details. That gives me a one-to-many between order and order details. I'll add products. I know there's a one-to-many between products and order detail. And then finally, categories. If I want to get a better look at this, I can right-click in the Object Relational Designer and choose Zoom. Let's zoom out to, say, 50%, and here's my model. I have 5 classes in here representing the 5 tables and relationships between them. Well, let's save this. And before we go querying, let's take a look at the code that Visual Studio generates for us. So I'll go into the Solution Explorer, and I want to look at northwind.designer.cs. So here's the code that defines my object model. Northwind data context inherits from system.data.link.dataContext, and the data context is how I connect to the database, how I retrieve data, and the data context is responsible for connecting to the database, retrieving data, tracking changes, sending changes back. So the data context is the conduit, if you will, between my application and the data. Now, how do I know which database we're working with? Well, Northwind data context uses the database attribute, and the name argument there is set to Northwind. Now, in the Northwind data context constructor, we're going to use Northwind connection string, and that's a project level setting that contains the connection string to the database. So now we know how to talk to the server and which database we're working with. When I drag the tables onto the Object Relational Designer, I created classes, and each of those classes is going to wind up as a property of the data context. So the data context has a property called customers, one called orders, order details, etc. And each of those are of type system.data.link.table, and it's a generic table, and in the case of customers, the table is made up of instances of the customer class. And in the getter, when I read that property, it calls the getTable method of the data context class, and that's going to create the table of instances of customer. Now, the interesting thing about system.data.link.table is that it implements IEnumerable, and that's why we can do LINQ to SQL queries based on the object model. Let's take a look at the entity classes. Here's the customer class, and it uses the table attribute, and the name argument on that is set to dbo.customers. And that's how we know that the customer class maps to the customer's table in the database. Now, this class implements iNotifyPropertyChanging and iNotifyPropertyChanged, and it uses property changing event args, and that's how the data context tracks changes. There's a backing variable for each of the properties in this class, and each property represents a column in the table. So here's the customer ID property, and it uses the column attribute to identify which column in the table this property maps to. The storage argument tells me which backing variable we're using. dbType tells me the type definition from the database. So customer ID is ncar5, not null. The canBeNull argument tells me that this field can't be null, and isPrimaryKey set to true tells me that customer ID is the primary key. When I make a change to this, notice the use of onCustomerIDChanging, sendPropertyChanging, sendPropertyChanged, and onCustomerIDChanged. And again, that's how the data context tracks changes. Company name can't be null, contact name can be null, etc. Let's go take a look at the orders property. The customer class has an orders property, and that's going to represent the orders for this customer. And it uses the entity set. So this orders property is a generic entity set consisting of instances of the order class. And the relationship is identified through the use of the association attribute. The name of the association is customer_order. The information stored in the _orders backing variable. This key set to customer ID tells me that we'll use the customer ID property in the customer class to go find orders, and other key is the property in the order class that we'll use. So now we know that the association is based on customer ID in the customer class to customer ID in the orders class. Let's go take a look at the order class. And the order class has an entity set that represents the details for each order, and it has an entity ref to reference back to the parent entity. So let's go take a look at the customer property in the order class. And that's down here. Again, we have an association, customer underscore order. This key is the customer ID in the order class, pointing back to customer ID in the customer class, and the is foreign key tells us that the order class, which we're currently in, is the child side of the relationship. And so this customer property is going to point back to the customer that owns the order, or literally the instance of the customer class that's associated with this order. So that gives you a good idea of the type of code that Visual Studio generates when you create your model. Now you may be asking yourself, well, we have our model, and now we can start querying, so why didn't we just go straight to querying? Well, there are several good reasons why we just looked at the code. First of all, it's always a good idea to have a high-level understanding of what happens when you use a designer or a wizard in Visual Studio. Also, if you understand the mechanics of how LINQ to SQL stores information and also maintains relationships, then I think it's easier to write LINQ to SQL queries and to understand the queries you're going to write. And then finally, you don't have to use the Object Relational Designer to create an object model. You can write the code by hand. Now, you'll probably typically use the Object Relational Designer, but you could write code that looks like this, and your LINQ to SQL queries would work just fine. And by taking a look at the classes, and particularly the attributes that tell us how the object model maps to the database, you now know the type of code that you would need to write if you created your own model. And now that we have our object model, we can start querying on it, and we'll do that in the next section.